All right, today we're going to look at doing some more with exponents, but we're going to use variable bases instead of number bases. So you need to know all your numbers, now we're going to bump it up a little with variables, so no numbers. There is a introductory video for people. There should be one, but this is assuming that you have some knowledge. So one thing is all of our laws of exponents. Anything to the 0 power is 1. Negative exponents basically flip, and if it's to a negative number, it's 1 over a to that power. So these are all talking about the fact that negative exponents basically are reciprocals. We have our fraction exponents, and remember that the root, if you think about the tree, the root is always on the bottom, and so that's true even when we have variables or numbers. And then our basic ones, when you multiply two things with the same base, you add their exponents. When you take a power to a power, you multiply your powers, and when you divide, you are subtracting. And similarly, you can distribute over multiplication. What is not true, for the record, this does not equal a to the m plus b to the m. That does not work. So you want to watch out for that. But otherwise, if you have a negative exponent outside, you can just flip and distribute. So let's jump in. Let's try a few. A little bit trickier. So here we have same base, multiplied together, two different powers. We are going to add our powers. So this is going to be y to the 6/3, otherwise known as y squared, right? Should be fairly easy. One thing to be careful about in something like this is we must distribute to everything. Everything in here gets squared. If you think about this, squaring means multiplying by itself. So really, that's what we have. And so we have 25 times 3, which is 75. I have an a, another a, and an a cubed, a to the 5th. And I have a b cubed and another b cubed is b to the 6th. You can also think of this as 5 squared, a squared, b to the 6th, and then times 3a cubed. We get our same answer. 5 squared is 25 times 3. There's our 75. A squared times a cubed. There's our a to the 5th. And then we have a b to the 6th. So, but then the one thing people often forget is distributing the 2 to the constant as well. All right, we can try this one. So we're going to take everything in here to the 1/3 power. Well, 8 to the 1/3, the cube root of 8 is 2. When I take m to the 6th to the 1/3, we are really multiplying our powers. So we're going to take 2, and 6 times 1/3 is 2. And when I take n cubed to the 1/3, I'm going to get n to the 1. And then I still have my 7m cubed. When I combine this part, we're going to get a final answer of 14m to the 5th n. So fraction exponents are roots. I mean, you could also say what cubed would get me m to the 6th. M squared cubed would get me m to the 6th. You can just multiply your exponents. When we get to dividing, so our rule says you can take p cubed and you can subtract that -2. So that's one way to think about this, and we would get our 4 and then p to the 5th. Or you can think of this as 4p cubed over 1 and 1 over p to the -2. Well, that negative exponent causes us to flip. In either way, I'm going to get the same answer of 4p to the 5th. So generally when I have negative exponents and it's all multiplying, I just flip them if they're in the bottom into the top, and if they're in the top, they go into the bottom. All right, something like this. Well, I am a big fan of getting rid of any negative exponents right away. So I can get rid of my negative exponents by flipping that up. All of that is to the 1/2 power. And then I multiply in. When I have a power to a power, I multiply. And so I'm going to get r to the 2 times 1/2, and s to the 1/2 times 1/3 is going to be 1/6. And there is my answer. Right, because we multiply our powers. If we try this, you can subtract your powers. So I have a to the 5/3 over a to the 1/3, and what I do is it's the same as a to the 5/3 minus 1/3. and that's going to give me a to the 4 thirds. My 4 is not raised to any power, so my final answer is 4a to the 4 thirds. And if you think about this, really, what you have is 5 cube roots all lined up. 1, 2, 3, 4. Oops, 5. And then I have 1 cube root on the bottom multiplied, and what happens is this cancels one of them, and we're left with 1, 2, 3, 4. With the cube root of a to the 4th, well, that's the same as a to the 4 thirds. So that's sort of what we're doing there. Here we go, simplify. So there's a bunch of things going on. I generally like to work inside out. So I'm going to deal with that negative right there first. And I would write this as 3y over 2. And if I have x to the 1, and I pull that x cubed down, remember, once you flip, the negative is gone. I still have all that to the negative 2. Well, that's the same. I'm going to deal with the negative here. So I'm going to take this x1, x cubed, that's an x to the 4th. That's going to flip to the top. The 2 is going to flip to the top. And the 3y is going to flip to the bottom. So now I've gotten rid of my negative exponent. And now it's about squaring everything. And do not forget to square your constants. 2 squared is 4. X to the 4th squared is x to the 8th. 3 squared is 9. And y squared is just y squared. And you can think about x to the 4th squared is x to the 4th times x to the 4th, which then becomes, we add our powers, x to the 8th. So if that helps to think about that and write it out that way, you certainly can do that. Let's try one last sort of complicated problem. I'm going to get rid of the negative 1 outside first. I generally work inside out, but not always. So there's multiple paths to getting the correct answer here. So you can do whatever you want. Let's get rid of the negative 1 outside. That's going to give me a 5, a to the negative 5 over a to the negative 3 b squared times 3a b cubed. I'm going to put that over 1 because that really is over 1. Again, you can just try and get rid of this. You could say negative 5 minus negative 3 is a negative 2, so that would give me an a squared in the bottom. Or if you like to go step by step, this gives me an a to the 5th in the bottom, an a cubed on top. And notice the things with positive powers do not move at all. They stay where they are. It's only things that have negative powers. And I can do this shifting as long as it's only multiplying. If I had something like a to the negative 5 plus b squared, I can't deal with this. I could split this up into 2 separate fractions, but I can't just flip the a to the negative 5 down there. That would not work. All right, so let's come back to this problem. We're still not done. I have 3 a's and 5 a's. It's going to give me 5. I have an a squared on the bottom, a b squared, and I have 3a b cubed. And now if I think about what cancels, one of these will cancel that. These will cancel and leave 1 there, and I'm left with 15b over a. You can also think of it as b, so cubed minus squared, that leaves 1b on the top. And here I'd have 4 on top, 5 on the bottom, that leaves 1 on the bottom. So there's your final answer. Hopefully now you'll have enough to attack the problems tomorrow in class.